Okay, afternoon, lads. We've worked through a fair bit of the mechanics unit so far and the forces and motion unit, and we're coming to the end of it. We are now at a stage where the questions that we're going to be attempting are going to be quite difficult and require a lot of different processes to get to the right answer. So I'm going to do a work solution now. What I would like you to do as I do this is work along with me. So everything that goes on this piece of paper should be going into your notes in your book as well. And we'll try and do a couple of different ones of these and then give you an opportunity to try and practice using the same technique yourselves. So in these problems, you often have a collision between two objects. Now, in this particular example, a car of mass 1,000 kilograms collides with a stationary motorbike of mass 250 kilograms. And it tells you in this problem that the car is travelling at 25 metres per second before the collision. And as a result of the collision, they stick together and then they both move off together after the collision. Now, the question is asking you to work out what speed are they moving at after the collision. And we're going to be using what we've been learning about momentum, and in particular, the conservation of momentum. Part of the challenge with these questions is how much information you are given. So the first thing I need you to do when you see one of these questions is I need you to highlight the information you've been given. So we've got the car's mass, which is 1,000 kilograms. The motorbike's mass, 250 kilograms, a bit lighter. And the car is travelling at 25 metres per second before the collision. So those are the numbers you've been given. And you're being asked to work out what speed the car is going to be travelling at after the collision. Once you've highlighted your numbers, your next step is to draw a diagram. And for these diagrams, we have a before situation and then an after situation. And to save time, you don't want to be wasting time drawing out diagrams of cars and motorbikes. Everything just needs to be a blob. So, to begin with, you have one blob, the car, and we've got another blob, the motorbike. Now, we know the motorbike's stationary beforehand, so it's just sitting there doing nothing. Now, we can draw an arrow here to show the car's speed. And we can label that arrow 25 metres per second. And we can also label that diagram with the masses of each object. So you've got 250 kilogram motorbike and then 1,000 kilogram car. And that's just a visualization of what's going on before. And it helps you to draw the numbers together. So then we look at the after situation. Well, it tells you they both stick together. So rather than having two separate blobs, the car and the motorbike, we're going to have one big blob, the car and the motorbike. Now, we know that's moving after the collision, so we can put an arrow there. So we've got our diagram, our before and our after situation. The next thing to do is to try and work out what that question is asking us to work out in our diagram and to give it a label. Now, like you do in maths, the things that you don't know should be given the letter X. Doesn't matter what letter you call it, but we'll stick with giving it X for the time being. So we're looking for the speed of the car after the collision. So that's represented by this arrow there. So we can just call that X. We now know what we're looking for. There's one thing that's missing for that diagram, and that's the mass of this blob. Do we know it? Well, we've got the mass of the motorbike and we've got the mass of the car, so it's just both of them added together. So after, we've got 1,250 kilograms, the mass of both of them stuck together. Now, once you're at that stage, you've got your diagram with your numbers. Your next step is to actually apply the conservation of momentum. Now, from the previous lessons, we've looked at the conservation of momentum. What's that saying? Well, it's saying that the momentum must be the same before as it is after. And we'll talk about different things we assume, but that's the main thing about the conservation of momentum. So once you've written that, you can just write out momentum before equals momentum after. And this is then when we're going to try and draw on what we've got in our diagrams. Now, just a reminder here, our formula for momentum equals the mass times by the velocity. So, what is our momentum before? So we don't have to go through each object. What's the momentum of the motorbike before? It's zero. It's not moving. So we've got the momentum of the motorbike, which is 0. And we've got to add that to momentum of the car. Now the car is moving, carrying momentum, mass times velocity. Our mass is 1,000 times by our velocity, which is 25. And that's going to be equal to the momentum after. So what is our momentum after? Well, we've got this one big blob, which remember represents the car and the motorbike stuck together. And we know its momentum is going to be its mass times velocity. So 1,250 times by its velocity. Well, what do we call the velocity there? We called it x. We don't know what it is. Simplify that equation and evaluate where we can. So we can work out that bracket. 1,000 times by 25 just gives you 25,000. Obviously the 0 doesn't make a difference there, so that's just ignored. And that's equal to 1,250 times by x. We're almost there. Here we've got x, which is what the question is asking us to work out there, the speed at which they're both moving. So we need to rearrange that equation to find x. Now, luckily, it's not too tricky. At the moment, we've got the x is being multiplied by the 1,250. So to get the x on its own, we've got to do the opposite of timesing by 1,250, which is dividing by 1,250. So we divide both sides by 1,250. At that point, we get our calculators out. So because on the right-hand side of the equation there, we've just got x, and then we've got 25,000 divided by 1,250. And it gives us 20. What's our answer missing there? The units. So going back then, reminding ourselves what we've just worked out. We've worked out a speed. We know that speed, like it's up here, is measured in meters per second. So we know our final answer here is x equals 20 meters per second. Now, these are likely to be some of the most challenging questions that come up on the higher tier paper. They won't be on the foundation paper, but on the higher paper, these might come up as a 4 or 5 mark calculation question. So this lesson is really just dedicated to give you time to doing a little bit of practice with it. I'm going to go through one more work solution with you, and then I'm going to upload the questions for you to have a go at yourself.